Welcome back to R for Economics. In this one, we're going to be looking at the ridge regression, which is another regularization or shrinkage approach to reduce the number of parameters so that you don't have to have as many regressors. Now, we're going to bring in our package, glmnet. Might take a minute to do. And then we'll load our library. Now, this will be very similar to what we saw in the lasso video, where we're going to choose the number of observations at 100. So the setup is going to be the same. So if you want specific details, I would suggest that you go and watch the lasso video for this. We're going to have 100 observations for training, 25 for testing, and we have 75 regressors that we could be using. For the training set, we're going to use a standard normal error, and we're going to draw from the normal distribution for our regressors as well. And similarly for the training testing set, but it's only going to be 25 observations. So again, this is going to lead to a loss of degrees of freedom where we have 100 observations and 75 regressors, 76 when including the constant. Now, if only the first 5, and this is a function to generate the first 5 to be significant, if only the first 5 are important, then all these other ones, these other 70, are actually just putting in error. So we want to be able to remove those. So if we generate our series, our y and our y0, which is our testing set, we can run OLS, and we're going to get 2.918. Now the ridge regression, here, we're going to use a glmnet function. We're going to give it x and y, and then we're going to set alpha is equal to 0. And again, it's the Gaussian family. And we can print this, and we can see how many degrees of freedom it wants to have. And we can see that it seems to increase right away. There's no stabilization that we saw in the lasso model. So here, the ridge regression is minimized out at 75. So it wants to have the entire model included, so all regressors. So there's no shrinkage benefit from this approach. And we can see that the cross-validated one is saying, oh, all the regressors are important. Even optimizing this, we end up with the same thing. And in fact, we end up with a predicted error in the optimized, which is even larger. Even larger than what we have for the OLS. Okay, and this can be seen in the comparison here. So the ridge regression in this case is not actually helping. So this may be a situation where you'd actually want to use something else. So you might want to move to the lasso because you've tried both, and you'd say that the lasso is an improvement because its predicted error is an increase. We can see that the regressors have increased, and it's saying it wants all 76 regressors. Okay. All right. Thank you, and we'll see you in the next video.